Hello students, now we will see summation of series based on binomial series expansions. We know some of the binomial series expansions, that is 1 plus x raised to n equal to 1 plus nx plus n into n minus 1 by 2 factorial x square plus n into n minus 1 n minus 2 by 3 factorial x cube plus etc. 1 plus x the whole raised to minus n equal to 1 minus nx plus n into n plus 1 by 2 factorial x square minus n into n plus 1 n plus 2 by 3 factorial x cube plus etc. 1 minus x raised to n equal to 1 minus nx plus n into n minus 1 by 2 factorial x square minus n into n minus 1 n minus 2 by 3 factorial x cube plus etc. 1 minus x raised to minus n equal to 1 plus nx plus n into n plus 1 by 2 factorial x square plus n into n plus 1 n plus 2 by 3 factorial x cube plus etc. By giving n equal to 2 in the expansion 1 minus x raised to minus n, the binomial series expansion will be 1 plus 2x plus 3x square plus 4x cube plus etc. So we will see a problem now. So the question is, find the sum of the series n sin alpha plus n into n plus 1 by 1 into 2 sin 2 alpha plus n into n plus 1 n plus 2 by 1 into 2 into 3 sin 3 alpha plus etc. So take it as S and C as 1 plus n cos alpha plus n into n plus 1 by 1 into 2 cos 2 alpha plus n into n plus 1 n plus 2 by 1 into 2 into 3 cos 3 alpha plus etc. Then C plus IS will be 1 plus n into cos alpha plus I sin alpha plus n into n plus 1 by 1 into 2 cos 2 alpha plus I sin 2 alpha plus etc. And we know that cos alpha plus I sin alpha equal to e raised to I alpha. So it will become 1 plus n e raised to I alpha plus n into n plus 1 divided by 1 into 2 e raised to I2 alpha plus etc. Looking at the above binomial series expansions, it will be of the form 1 minus e raised to I alpha the whole raised to minus n. Replace e raised to I alpha by cos alpha plus I sin alpha. It will be 1 minus cos alpha minus I sin alpha the whole raised to minus n. And we know that 1 minus cos alpha is 2 sin square alpha by 2 and sin alpha can be written as 2 sin alpha by 2 cos beta by 2. So substituting these values, it will be 2 sin square alpha by 2 minus I2 sin alpha by 2 cos alpha by 2 the whole raised to minus n. So in these two terms 2 sin alpha by 2 is common, so we can take that term out and it will be 2 sin alpha by 2 the whole raised to minus n, that will be 2 raised to minus n sin raised to minus n alpha by 2 into sin alpha by 2 minus I cos alpha by 2 the whole raised to minus n. And we know that sin x can be written as cos pi by 2 minus x. So replace sin alpha by 2 by cos pi by 2 minus alpha by 2. Similarly, cos alpha by 2 can be replaced by sin pi by 2 minus alpha by 2. Okay, so C plus IS will be 2 sin alpha by 2 the whole raised to minus n cos pi by 2 minus alpha by 2 minus I sin pi by 2 minus alpha by 2 the whole raised to minus n. And by applying de Moivre's law, that is cos theta plus I sin theta the whole raised to n equal to cos n theta plus sin n theta, C plus IS will be 2 raised to minus n sin raised to minus n alpha by 2 cos minus n pi by 2 minus alpha by 2, and we know that cos minus x equal to cos x, so we can write cos n pi by 2 minus alpha by 2. Also sin minus x equal to minus sin x, so here minus sin pi by 2 minus alpha by 2 will become plus I sin n pi by 2 minus alpha by 2. So we can equate the real and imaginary parts. So the real part c will be 2 raised to minus n sin raised to minus n alpha by 2 cos n pi by 2 minus alpha by 2, and imaginary part s equal to 2 raised to minus n sin raised to minus n alpha by 2 sin n pi by 2 minus alpha by 2, and we need to find the imaginary part. So the summation of the series is 2 raised to minus n sin raised to minus n alpha by 2 sin n pi by 2 minus alpha by 2. Okay, now we will see another problem. Find the sum of the series cos alpha nc1 cos alpha plus beta nc2 cos alpha plus 2 beta nc3 cos alpha plus n cos alpha plus 3 beta plus etc. Okay, then take c as cos alpha plus nc1 cos alpha plus beta plus etc. and replace cos by sin, that will be s equal to sin alpha plus nc1 sin alpha plus beta plus nc2 sin alpha plus 2 beta plus etc. So c plus is will be cos alpha nc1 cos alpha plus beta nc2 cos alpha plus 2 beta plus etc. plus I sin alpha plus nc1 sin alpha plus beta plus etc. and cos alpha plus I sin beta will be e raised to I beta. So substituting that, we will get e raised to I alpha plus nc1 e raised to I alpha plus beta plus nc2 e raised to I alpha plus 2 beta plus etc. So in each of the terms in the summation e raised to I alpha is common, we can take that out. So it will be e raised to I alpha into 1 plus nc1 I beta plus nc2 I 2 beta plus etc. And looking at the above binomial series expansions, it will be of the form 1 plus I beta the whole raised to n. So c plus is will be e raised to I beta into 1 plus e raised to I beta the whole raised to n, and replace e raised to I beta by cos beta plus I sin beta. Also 1 plus cos beta can be written as 2 cos square beta by 2 and sin beta by 2 cos beta by 2 sin beta by 2. So it will be e raised to I alpha 2 cos square beta by 2 plus I 2 cos beta by 2 sin beta by 2 the whole raised to n. And in these two terms 2 cos beta by 2 is common like the above problem, so we can take that out, that term out. So it will be like e raised to I alpha 2 raised to n cos raised to n beta by 2 cos beta by 2 plus I sin beta by 2 the whole raised to n, and cos beta by 2 plus I sin beta by 2 will be e raised to I beta by 2. So it will become e raised to I n beta by 2. So it will be e raised to I alpha plus n beta by 2 2 raised to n cos n beta by 2, and expand the e raised to I alpha plus n beta by 2, it will be 2 raised to n cos raised to n beta by 2 cos alpha plus n beta by 2 plus I sin alpha plus n beta by 2. So we can separate the real and imaginary parts. Equating the real and imaginary parts, c is 2 raised to n cos n beta by 2 cos alpha plus n beta by 2, we had to find the real part. So the answer is 2 raised to n cos raised to n beta by 2 cos alpha plus n beta by 2. Okay, so I can share the notes, refer that also. Thank you.